Welcome to the campus of MIT, the Massachusetts Institute of Technology in Cambridge, Massachusetts. You might think of MIT as a great place to learn about science and technology, but here's something you probably didn't know. MIT is also a great echo chamber. In order to make an echo, we need a source, or something to make a sound, and we need a reflector, or something to bounce the sound back to us. In this case, we're going to use this balloon as a source, and those buildings over there as a reflector. Ready?
An echo is just a sound that bounces back to our ears. When the balloon pops, waves of pressure, called sound, are released into the air. In the air, these waves travel really fast, at 760 miles per hour, way faster than your car. We can hear these sounds either directly or after they've bounced off something. Sound bounces elastically, like these balls, off the wall. The farther away from the wall you are, the longer it takes for the sound to come back. We can also draw sound waves as pictures, called waveforms. In this picture, time goes to the right, and the thickness of the blue shape shows how loud the sound is over time. Let's listen to our balloon once again, this time with the picture. As you can see, there are 2 points when the sound is loudest. These represent the balloon popping and traveling to our ears directly, and its echo. Now, to hear the echo, the sound had to travel all the way to the buildings and all the way back. By measuring the time between the first sound and the second, we can estimate the distance between us and the buildings. In this case, it took 0.2 seconds, which corresponds to a distance of about 30 meters. But what happens if we make sounds in a different place, like this amphitheater? We can see by throwing the balls in different directions, the sound will bounce back to us at the same time from all of these directions. Let's hear what it sounds like. Comparing this waveform with the old one, we can see that the time between the balloon popping and its echo is much shorter, 0.025 seconds, which is about a tenth of what we heard before. So the distance is only about 4 meters. Okay, what about a different space, like this hallway?
This space is cool because we have 2 walls that are really close, so the sound's going to bounce back really quickly, and 1 wall which is really far away, and it's going to take the sound a while to bounce back, if ever.
We can compare this waveform with the previous ones and see that the sound actually does come back. In this case, it takes 0.4 seconds, corresponding to a distance of about 60 meters. But what if we could find a space where sound didn't come back?
This is a recording booth, which is used to make radio pieces. The idea here is to absorb the sound so it doesn't echo. To do this, we have thick doors, which are covered in carpet. Inside, we can also see these pieces of fabric, which are going to absorb sound the same way they absorb the bounces of this ball. I'm going to shut myself inside and see if we do, in fact, get no echoes. Let's find out.
Once again, we can look at the waveform to better understand what's going on. Here, we see when the balloon pops, but look, no echo. But does popping balloons all over campus have any actual applications? Is any of this actually useful? Turns out it is. Both animals and humans use echoes for a variety of purposes. By sending sounds through the water, some animals, like dolphins and whales, can use the sound to find their way in the dark. When these sounds bounce off objects like fish, dolphins are able to detect the echoes and know where the fish are. By studying how sound works and travels through materials, scientists and engineers are able to use a system called sonar to find things in the ocean. Sonar works by bouncing sound off of objects, like the bottom of the ocean, and measuring the time it takes to receive the echo, just like we did with the balloons. The closer the object, the shorter the time. By taking many different measurements, scientists and engineers can even form maps of the ocean floor in places you can't see with light. Sometimes they can even form images of shipwrecks or fish, which might be similar to how dolphins see them.
Sound travels through materials and carries with it information about the world around us. If you listen carefully enough, you can hear the whole world in a single